So we're going to be looking at some questions in this exam review. Number 1, when you have two radical signs, what you need to do is isolate one of them and then square both sides. In this case, one of them is already isolated. This one's by itself on the left side, so we're good with that part. And now we're going to square both sides. When you square both sides, the left side is 3a minus 8. On the right side, we actually need to multiply this thing out. So you could go ahead, since it's squared, it's multiplied by itself, and we can multiply that out. So we have 1 minus root 3a minus 3, and then multiplying here, we have minus root 3a minus 3, and then when we multiply the last ones here, it's multiplied by itself, so the square root kind of cancels, and it is just 3a minus 3. We'll add some like terms here on the right side. So we have a 1 and a negative 3, which is negative 2. These two added together is negative 2. Root 3a minus 3 plus 3a here. And now we have one radical, so we're going to isolate that radical. We're going to get everything to the left side. So we'll subtract 3a from both sides, and we'll add 2 to both sides, which gives us 0. Then we have negative 6 equals, these two become 0, negative 2, root 3a minus 3. And we can divide both sides by negative 2 to isolate this radical. And we get 3 equals square root of 3a minus 3. Squaring both sides gives us 9 equals 3a minus 3. Add 3 to both sides, so 12 equals 3a, and divide by 4, a equals 4. Since we squared both sides, we need to check our solution, so we need to go ahead and put it back in the original. So we have the square root of 3 times 4, so I'm putting it back into the original, minus 8. And we want to check, does that actually equal negative 1 times 3 times 4 minus 3. Sorry, plus that, not times. So over here on the left, we have 12 minus 8 is 4, the square root of 4, and then negative 1 plus 3 times 4 is 12, minus 3 is 9, and this is 2. And negative 1 plus 3, it does in fact work, so a equals 4. Going right to number 2. Again, we want to isolate the radical. It actually is isolated already, so we can just square both sides. And so we have m squared equals, the square root cancels with the squared, and we have 2 minus m. This is a quadratic equation, so we want to get everything to one side and see if we can factor. So we'll add m and subtract 2, add m and subtract 2, and then we factor, which this one does factor nicely, m and m. To get a negative 2, we need one positive and one negative, and it looks like it'll be positive 2 and negative 1. So m equals negative 2 or 1. Again, since we squared both sides, we need to check to see if they're correct or if they work. So I'm going to actually erase a little work here, so we're going to put that in the original. So we're going to plug in negative 2. Does negative 2 work? Well, without even going further, and you could go further and check it, but a square root never equals a negative, so negative 2 does not work. Now check 1. Does 1 equal 2 square root of 2 minus 1. And thinking through that, 2 minus 1 is 1, square root of 1 is 1. That does work. So our answer, that shouldn't have been there, is m equals 1.